This is the story of how the universe will end. So, turn off the lights, lie down and look up. Imagine you are in the middle of a vibrant spiral galaxy. Around you, countless blue and pink nebulas swirl and shine. And in the distance, you see countless stars winking on and off like a celestial firefly. At the center of the galaxy, gold light streams out from a massive, glittering core. As you fly towards it, more and more stars come into view, forming clusters of shining diamonds. Then, just as suddenly, the view clears. You are alone once more. The universe today is a vibrant home, filled with light and energy. But this won't last forever. In a few tens of billions of years, the first stars will die. Those giants blazing across the cosmos will run out of fuel and go out like candles in the wind. Then sun-like stars will begin to wink out one by one. Entire galaxies will grow dimmer as the night wears on, and the universe will slowly turn cold and dark. In 1 trillion years, most of the stars will die. Only red dwarfs will remain, glowing embers in an encroaching darkness. In another 1 trillion years, even those long-lived stars will fade. The universe will enter its dark age. Black dwarfs will float in infinite space. Cold and dead. All that will be left are black dwarfs, the cold, dead cores of stars, colder than space itself. Imagine if you could drift through a galaxy of these dying stars. You would see countless little flickers, each one hiding a tremendous amount of mass. Inside these cosmic corpses, a silent battle rages. Gravity wants to crush the star, but a quantum force fights back. Electrons trapped inside the star push against the relentless pull of gravity, keeping it aloft. But there aren't very many electrons to go around. As the star ages, it loses more and more of them to the crushing pressure in its core. Imagine these electrons as passengers on an infinitely crowded train. They hate being squeezed, and their pushing holds the star up. But each time a passenger vanishes, the crush of gravity gets a little stronger. Imagine riding this train as it slowly crumbles around you. The floor gives way beneath your feet. You grab for support, but all around you, fellow passengers are disappearing. You can feel the walls trembling. Now you're alone, and the walls are bending inward. The train is collapsing. This is what happens when a black dwarf loses its last electron. Gravity wins the battle. The dwarf implodes, shaking the foundations of the universe. But even as the star collapses, its core stays hot and pressurized. Atomic nuclei inside vibrate slowly. If you were close enough, you wouldn't hear anything. Sound needs air, but you could see something incredible. Every so often, 2 of those nuclei will suddenly flash. That flash is a shock wave, rippling outward from a miniature fusion reaction. The nuclei have fused, creating a slightly heavier element, and a few precious moments of light. This process eventually creates unstable elements that decay. They break apart, releasing energy in a subatomic particle called a Electrons and positrons are identical except for their electric charge. When one of these ghostly particles drifts toward an electron, they will collide and annihilate, vanishing from existence. This leaves behind empty space where there was light. Each annihilation is a disaster. It removes a passenger holding up the walls. As time passes, more and more stars go out. The train cars grow empty. You find yourself wandering through an echoing void, past collapsed train cars and vanished passengers. The darkness presses in on you. There isn't even light to look at. The entire universe is a silent, empty void, and that is eternal. But this event is so impossibly far in the future, it might as well be never. For us, now the universe is vibrant, beautiful, and alive. And that means our time to explore and understand it is precious. Now, let's get to work. We want to know more about the amazing nature of our universe.